Hi everyone, this is G.RATHNA SRI, Assistant Professor of Chemistry, A.D.M. College for Women, Autonomous, NAGAPATTINAM. In today's session, we are going to discuss about several topics for allied chemistry and from the unit 1. And the topics are going to be chemical bonding, types of chemical bonding, molecular orbital theory, and magnetic properties of molecules. First, let's start with the definition for chemical bonding. A chemical bond is the association of atoms or ions to form molecules, crystals, and other structures. Chemical bonds are described as having different strengths. There are strong bonds or primary bonds such as covalent, ionic, and metallic bonds, and weak bonds or secondary bonds such as dipole-dipole interactions, the London dispersion force, and hydrogen bond. The atoms in molecules, crystals, metals, and other forms of matter are held together by chemical bonds which determine the structure and properties of matter. Now we know what is chemical bond, but let's see why a chemical bond is formed or needed in the first place. The reason for that is the octet rule. The octet rule detects that atoms are most stable when their valence shells are filled with 8 electrons. The octet rule is only applicable to the main group elements. The molecules of the halogens, oxygen, nitrogen, and carbon are known to obey the octet rule. In general, the elements that obey this rule include the S block elements and the P block elements, except hydrogen, helium, and lithium. Upon observing that the noble gases were chemically inert, the electronic theory of valency was proposed by the German physicist Walther Poiseuille and the American physicist Gilbert Lewis. It was based on the tendency of atoms to assume the most stable state possible. There is more exceptional molecules that do not obey the octet rule. Since 1p subshells do not exist, some elements find stability in 1s2 configurations. On the other hand, some elements exhibit hypervalency and have the ability to form hypervalent molecules. Some elements that obey the octet rule includes hydrogen, lithium, phosphorus, and sulfur. Next, let's move on to the topic types of chemical bonds. And let's discuss in detail about the two major types of chemical bonds, and they are the covalent bond and the ionic bond. First, in the covalent bond, elements having very high ionization energy are capable of transferring electrons, and elements having very low electron affinity cannot take up electrons. The atoms such elements tend to share their electrons with the atoms of other elements or with other atoms of the same element in a way that both the atoms obtain octet configuration in their respective valence shells and thus achieve stability. Such association through sharing of electron pairs among different or same kind is known as a covalent bond. For example, nearly all the hydrocarbons have covalent bond. Next is the ionic bond. The electrostatic force of attraction which holds the two oppositely charged ions together is called the ionic bond. A chemical bond is formed between two atoms from one atom to the other as a result of which the atoms attain their inert gas configuration. There are primarily three ways in which two atoms combine to lose energy and to become stable. One of the ways is by donating or accepting electrons to complete their octet configuration. The bond formed by this kind of combination is known as an ionic bond or electrovalent bond. This kind of bond is formed when one atom gains electrons while the other atom loses electrons from its outermost level or orbit. Example are NaCl, HCl, etc. Now let's see what is a molecular orbital before going into the topic molecular orbital theory. A molecular orbital, the space in which in a molecule in which the probability of finding an electron is maximum can be calculated using the molecular orbital function. Molecular orbital are basically mathematical functions that describe the wave nature of electrons in a given molecule. These orbitals can be constructed via the combination of hybridized orbitals or the atomic orbitals from each atom belonging to the specific molecule. Molecular orbitals provide a great model via the molecular orbital theory to demonstrate the bonding of molecules. Now let's discuss about the molecular orbital theory and its key features. Molecular orbital theory. The molecular orbital theory, which is often abbreviated to MOT, is the theory on chemical bonding developed at the beginning of the 20th century by F. Hunt and R.S. Millikan to describe the structure and the properties of different molecules. The molecular orbital theory proved to be more powerful than the valence bond theory, since the orbitals described by the MOT reflects the geometry of the molecule in which it is applied. Let's discuss about the key features of MOT. The key features of the molecular orbital theory are: first, the total number of molecules the total number of molecular orbitals formed will always be equal to the total number of atomic orbitals offered by the bonding species. Second, there exist different types of molecular orbitals: bonding molecular orbital, anti-bonding molecular orbital, and non-bonding molecular orbitals. Of these, anti-bonding molecular orbitals will always have higher energy than the parent orbitals, whereas bonding molecular orbitals will always have lower energy than the parent orbitals. Third, the electrons are filled into molecular orbitals in the increasing order of orbital energy, from the orbital with the lowest energy to the orbital with the highest energy. And last, the most effective combinations of atomic orbitals for the formation of molecular orbitals occur when the combining atomic orbitals have similar energies. Next, let's see the important and basic two types of molecular orbitals. The first type is the bonding molecular orbital. The molecular orbitals formed by the additive effect of the atomic orbitals are called bonding molecular orbitals. The probability of finding the electrons is more in the case of bonding molecular orbitals. These are formed by the combination of positive with the positive and negative with the negative part of the electron waves. The electron density in the bonding molecular orbital in the internuclear region is high. As a result, the nuclei are shielded from each other and hence the repulsion is very less. The bonding molecular orbitals are represented by sigma, pi and delta. The second type is the anti-bonding molecular orbitals. Molecular orbitals formed by the subtractive effect of atomic orbitals are called anti-bonding molecular orbitals. The probability of finding electrons is less in anti-bonding molecular orbitals. There is also a node between the anti-bonding molecular orbitals between two nuclei where the electron density is 0. There is formed by the overlap of positive with the negative part of the electron wave. The electron density in the antibonding molecular orbital in the internuclear region is very low, so the nuclei are directly exposed to each other. Therefore, the nuclei are less shielded from each other. Before seeing the examples for MOT, let's just take a quick look on the three major rules that we should keep in our mind while filling the molecular orbital. First rule is known as Afka principle. According to this principle, molecular orbitals are filled in the increasing order of energy levels. Second rule is Pauli's exclusion principle. This principle states that an atom or a molecule on no two electrons can have the same set of four quantum numbers. Third is the Hund's rule of maximum multiplicity. This explains that the pairing of electrons does not take place until all the atomic or molecular orbitals are singly occupied. Let's see how the number of bonds between the atoms in a molecule is calculated before going further into the topic. Calculation of bond order. Bond order is the number of chemical bonds between a pair of atoms. In a diatomic nitrogen, that is N triple bond N, for example, the bond order is 3. While in acetylene, that is C2H2 molecule, the bond order between the two carbon atoms is 2 and the two carbon atoms is 3 and CH bond order is 1. Bond order also indicates the stability of the bond. Next, let's discuss about the MOT of hydrogen molecule, that is molecular orbital theory diagram for the hydrogen molecule. Hydrogen molecule is formed by the combination of two hydrogen atoms. Each hydrogen atom have one electron in 1s orbital. Therefore, in all three are two electrons in the hydrogen molecule, which is present in sigma 1s molecular orbital. So, electronic configuration of hydrogen molecule is sigma 1s2. The bond order is calculated as the subtraction of electrons in antibonding molecular orbitals from the bonding molecular orbitals, and the answer is divided by 2. In hydrogen molecule, the number of electrons in antibonding molecular orbitals is 0 and the number of electrons in bonding molecular orbitals is 2. Thus, the bond order of hydrogen is obtained as 1. Thus, this means that the two hydrogen atoms are bonded together by a single covalent bond. The bond dissociation energy of hydrogen molecule has been found to be 438 kJ per mole. Bond length is equal to 74 ppm. Next, let's discuss about the molecular orbital theory diagram for nitrogen molecule. The atomic number of nitrogen is 7. The electronic configuration is 1s2, 2s2, 2p, 3. Thus, it contains a total number of 7 electrons. The two atoms of nitrogen combine together to form the N2 or the nitrogen molecule. Thus, the molecule contains 14 electrons in total. The bond order is calculated for the nitrogen molecule. The bond order is the subtraction of electrons in antibonding molecular orbitals from the bonding molecular orbitals, and the answer is divided by 2. Thus, in the nitrogen molecule, the number of electrons in antibonding molecular orbitals is 4 and the number of electrons in bonding molecular orbitals is 10. Thus, the bond order of hydrogen is obtained as 3. Thus, this means that the two nitrogen atoms are bonded together by a triple covalent bond. Let's move on to the last topic of this session, that is the magnetic nature of the molecules. The behavior of the molecules when placed in a magnetic field can be classified into two major types, and this behavioral changes in the molecule is due to the change in the number of electrons present in the molecule. The major two types include the paramagnetic and diamagnetic substances. First, let's see what is the paramagnetic substance and their properties. The definition of paramagnetic substances. First, The paramagnetic substance are the molecules or substances that contain the unpaired electrons in its molecular orbitals. For example, paramagnetic substances are nickel, chromium, titanium, etc. Properties of these paramagnetic substances. Paramagnetic substances are deeply attracted by the external magnetic field. Paramagnetic substances become diamagnetic under high temperature. Paramagnetic substances have relative permeability greater than 1. The magnetic susceptibility of the paramagnetic substances are positive. These substances do not show any levitations. Doped semiconductors show paramagnetism. Next, let's see what are the diamagnetic substances and their properties. The definition of diamagnetic substances. The diamagnetic substances are the molecules or substances that contain the only paired electrons in its molecular orbitals. For example, hydrogen, nitrogen, water, etc. Properties of these diamagnetic substances. Diamagnetic substances show slight repulsion by the external magnetic field. The temperature has no effect on diamagnetic substances. Diamagnetic substances have relative permeability is lesser than 1, and magnetic susceptibility of diamagnetic substances is negative. Diamagnetic substances show static magnetic levitation. Pure semiconductors show diamagnetism. We reached the end of this session. Let's now recall what we learned in this session. A chemical bond is the association of atoms or ions to form molecules, crystals, and other structures. And the octet rule. The octet rule dictates that atoms are more stable when their valence shell are filled with 8 electrons. Covalent bond. Covalent bond. Elements tend to share their electrons with the atoms of other elements or with the other atoms of the same element in a way that both the atoms obtain octet configuration in their respective valence shells and thus achieve stability. Such association through sharing of electron pairs among different or same kinds is known as covalent bond. For example, nearly all the hydrocarbons. Next is the ionic bond. The bond formed by donating or accepting electrons to complete their octet configuration is known as an ionic bond or electrovalent bond. Example, NaCl, HCl, etc. Next is the molecular orbital. The space in which the probability of finding an electron is maximum can be calculated using molecular orbital function. Next is the molecular orbital theory. The molecular orbital theory, which is most often abbreviated to MOT, is a theory on chemical bonding developed at the beginning of the 20th century by F. Hunt and R. S. Millikan to describe the structure and properties of different molecules, and then the key features of the molecular orbital theory. Next is the bonding molecular orbitals. The molecular orbitals formed by the additive effect of the atomic orbitals are called bonding molecular orbitals. The bonding molecular orbitals are represented by sigma, pi, and delta. Next is the anti-bonding molecular orbitals. Molecular orbitals formed by the subtractive effect of the atomic orbitals are called anti-bonding molecular orbitals. The anti-bonding molecular orbitals are represented by sigma star, pi star, and delta star. Bond order. The bond order is the number of chemical bonds between a pair of atoms. Then the molecular orbital theory for hydrogen and the nitrogen molecule. Next is the paramagnetic substances or the molecules or substances that contain the unpaired electrons in its molecular orbitals. Example for paramagnetic substances are nickel, chromium, titanium, etc. And the last is the diamagnetic substances. They are the molecules or substances that contain only paired electrons in its molecular orbitals. Example for diamagnetic substances are hydrogen, nitrogen, water, etc. That's it for today's session. Hope you all understand all the topics in this session. Have a nice day. Thank you.